As long as we are deep inside the nucleus, it's so cozy in here, can you talk about the binding energy and what makes protons stick together? Absolutely. It might not be as exciting as you think. It's largely empirical. And what I mean by that is that when we look, for example, at gravity, we can measure the magnitude of gravity and come up with a theory, general relativity, for what causes the observations. The same thing with electrostatics. If I have a charge in one distribution, a charge in another distribution, I can predict, based on Maxwell's equations, what the attractive force should be. When it comes to the nucleus, again, it's observed. We see that in the nucleus, the protons are attracted to each other and they're attracted to the neutrons. An analogy there might be looking at water. You can see that when you condense water below a certain temperature, the molecules are attracted to each other, and we can measure that, and we can come up with a model for the polarity of the molecules to describe how they're attracted and how you get the attraction between water molecules. When it comes to nucleons, protons and neutrons, it's largely the same thing. We look at the attraction that we see, and then we come up with a model using quantum electrodynamics to say what kind of virtual particle exchange has to occur for that. It's the same thing that we do with electrostatics. You actually look at virtual photons being exchanged between charges to come up with a very precise calculation of the attraction that you have between two like or opposite charges, whether that's a positive or negative attraction. And with the nucleus, again, it's the same thing. We measure the attraction that we see, and so we can come up with a measure for the size of the virtual particles that have to be exchanged. So it's just another force. Theoretically, gravity could be the same thing. You could be exchanging virtual gravitons, but it really is just empirical. How strong is that attractive force, and what in the standard model is it that's taking place that gives rise to that attraction? So I hope that answers the question. Maybe it did sound complicated. It's really just an empirical observation and matching that to the standard model. So thanks for asking the question. Hope you enjoyed the video. Have a good day.